Just take a look around you for a second. Everything you see, every screen, every building, it's all written in a kind of secret language. And today, we're going to learn the alphabet of that language, the simple but super powerful world of lines and angles.
That's right. From the device you're holding in your hand right now, all the way up to the stars in the sky, everything operates on a set of hidden rules. It's a code, really, based on shape and form, and together, we are about to crack it.
So, where does this incredible story of shapes and structures even begin? Well, it all starts with the absolute simplest, tiniest element you can possibly imagine, the point.
Now, think about this for a second. A point is kind of like a paradox, isn't it? It marks an exact location, but it has 0 dimensions, no length, no width, absolutely nothing. It's like a circle with a radius of 0. It's purely a position, and we usually mark it with a capital letter just so we have a place to begin our journey.
But here's the thing, points don't just exist in isolation. They form relationships. When they all line up perfectly, we call them collinear points. And when they're scattered all over the place, they're non-collinear. And the moment we start connecting these points, well, that's when the magic really begins.
We connect the dots, literally. From these individual points, we forge lines. And these aren't just simple drawings. You can think of them as the architectural blueprints of our entire reality.
So what is a line really? It's basically a chain of infinite points, all strung together one after another. And here's the part that might blow your mind. A true geometric line is infinite. It stretches on forever in both directions. A perfect path that has length, but absolutely no thickness. Wild, right?
Of course, we can't always work with the concept of infinity, right? So we break lines down into more manageable pieces. A line segment is a finite chunk with 2 clear endpoints. Think of it like a piece of string. Then you have a ray, which is kind of a hybrid. It has one starting point and then shoots off into infinity in one direction, just like a ray of sun.
Lines also have their own, personalities. A straight line is super disciplined. It never changes its path. A curved line, on the other hand, is constantly changing direction. When 2 lines cross paths, we say they intersect. If you get a whole crowd of 3 or more lines meeting at the same single point, they're concurrent. And then you have parallel lines. The perfect example? Railway tracks. They journey alongside each other, always keeping the exact same distance apart, but they are destined to never ever meet.
Now, there's a really special case of intersecting lines, perpendicular lines. They don't just cross paths, they meet at a perfect 90-degree angle. They form that clean, crisp corner you see on the edge of a book or a box.
Okay, so we've got points and we've got lines, but what happens at that exact moment when these paths meet, or when they start from the very same spot? Something entirely new is created, the angle.
An angle is really just a way of measuring a turn. When you have 2 rays shooting out from the same starting point, which we call the vertex, the space between them creates a kind of bend or inclination. And it's that turn that we measure as the angle. And just like there's a whole spectrum of colors, angles come in all sorts of different sizes. From tiny, sharp turns to wide, open ones, each one has its own name and its own identity. So let's meet the whole family, shall we? First up, we have the acute angle. This is any turn that's greater than 0 but less than 90 degrees. Like the sharp point on a slice of pizza. That's a classic acute angle. Land exactly on 90 degrees, and you've got the foundation for, almost everything we build, the right angle. It's that perfect corner you see on books, boxes, and the walls of buildings. Push past 90 degrees, and you'll find the wide, relaxed, obtuse angle. This is any turn that's bigger than a right angle, but hasn't quite opened up into a straight line yet. Keep opening it all the way up, and you'll hit 180 degrees. This is the straight angle, which, as you can probably guess, is simply a perfect straight line. But wait, we can go even further. A reflex angle is that larger outside turn, the one that bends back on itself. It's anything more than 180 degrees, but not quite a full circle. And finally, swing all the way around back to where you started, and you've created a complete angle. That's one full 360-degree rotation. The journey is complete. So there you have it. Points, lines, and angles. They seem almost ridiculously simple, right? But the rules that govern them are what give rise to all the infinite complexity we see in the world. Let's go over a few of those key rules.
And it all boils down to a few really elegant rules. For instance, an infinite number of lines can pass through any single point. But between any two distinct points, there's only one unique straight line that can exist. That's a fundamental law of connection. And if you zoom out, whenever two flat planes intersect each other, the place where they meet always forms another perfect line.
And all of this leaves us with one final amazing thought. From a point with no size, a line with no thickness, and the space created between them, literally every complex structure in our universe is built. So the next time you look at a building, a tree, or even a piece of art, you'll know the secret code. You'll know what it's written in.